Good morning, friends. Now we'll learn today about slider crank mechanism to be made on Geogebra and finally making a radial engine. So, here there are four pistons, namely E, H, C, and I. And here, as in IC engine, combustion takes place and we get rotary motion on D about point A. So let's start this video. So as we get, let's consider a single piston cylinder E. So now here the piston is enclosed in a cylinder in which it moves. So let's consider the strokes, considering this as expansion stroke, exhaust stroke, inlet stroke, and compression stroke. So these are the four strokes taking place in this. So this is the top dead center and this is the bottom dead center. So here in this GeoGebra we can find location of point D at different combustion positions of respective cylinders, like at which point all the cylinders will exactly stand when the value of D is considered 220. So this can be helpful for analysis of cylinders, that when if there is a knocking or noise at particular angle, we can find in which engine there is a problem. Okay, so now let's start how to build this slider crank mechanism. So new window. Okay, first we define a circle, point B. Now we define a slider from 0 to 360, naming it as small a. Okay, so now defining B equals to 4, considering radius as 4 sine of A, comma 4 cos of A. Okay, so now we get a point. Now let's make a second point on x-axis, because this point will act as piston and will move in single direction. So now for connecting rod, let's go to some theory. So let's study this distance formula. So here distance formula is given by x of f is equal to x coordinate of final point minus x coordinate of initial point square. So now in our case the initial point here is B and final point here is C. So as formula says that final point minus initial point square plus y of final point minus y of initial point square is equal to distance square. This is the distance formula. So in our equation, let's consider the distance to be 10. So our connecting rod is of 10 units and our final point is on x-axis, so y coordinate will be equal to 0. If we put the values in the equation, we get a final equation named x of final is equal to under root of 100 minus y of initial whole square bracket plus x of I. Okay, So let's use this equation to form our connecting rod. So let's define this point as 100 minus y of b square raised to 0.5, which is replaced by under root sign, okay, plus x of b comma 0, as the point here is on x axis. Okay, so applying this and joining this by a segment which will be known as our connecting rod. So as we start this animation, we get this fantastic view of this conics, and keep it increasing always. Okay, so we get a constant. Let's connect this b of animation. Let's connect a and b. So here we get a slider crank mechanism, and similarly if we tweak the values we get all other points. So let's pause this off. Let's use the coordinates of C. Only the under root sign will change, so it will be minus here. So if we connect this point for this, it will change the coordinate from 0 to 100 minus x of b and y of b, and similarly here there will be a minus sign, just a change by minus sign. Apply. Okay, so connecting this all points, we get this video. Okay, so if we want to change its color to some red, this color to green, this color to some purple, and this color to yellow. Okay, and if we trace these points, tracing is on C, D, E, F. So we get this illusion. So thanks for watching the video. You can check my other videos above here, and if you like the channel, subscribe it, and if you want to learn some analysis of particular mechanism, do comment. I'll surely look into it and make videos.